Tēnā koutou katoa. Koa ho Armin, nā mai haramai, and welcome. This is our TTEC Reboot panel event on the topic of aviation and urban air mobility. And it's something that actually we were hoping to share earlier on this year at our TTEC conference that was unfortunately cancelled due to COVID on the day. So a little bit about ITS New Zealand. We're a member-based organization and want to say a big thanks to all of our members. The gold and silver members are on this slide, but we also have a large number of bronze and research and academia members. And you can find out more about us and our members on our website, itsnz.org. Really, for us, we're a member-based organization that supports, promotes, and advocates for a more sustainable, safe, equitable, and efficient transport system. And we take a whole of system approach and multimodal lens to that. Aviation is a very important and significant part of a multimodal approach. And that's why we're keen to talk about the future of aviation and urban air mobility today. I'm a director and vice president for ITS New Zealand. And we also have Simon, who's an executive officer for ITS New Zealand, who will be taking questions at the end of our session today. So please use the Q&A console to ask your questions. And I'll be your host and moderator for today for our panel conversation. I also want to say big thanks to all of our panelists for showing up today and showing an interest in the future for New Zealand and from, I guess, also a more wider perspective. So having said all that, I'd like to hand it over to Richard, who will introduce himself. So I'll go to the next slide. Richard's from MOT, and over to you, Richard.
Kia ora koutou. I will try and make my introduction relatively brief so I don't have to stare at a photo of my face for too long. So I'm Richard Cross. I'm the manager of the Strategic Policy and Innovation team at Te Manatu Waka, the Ministry of Transport. So my team is responsible for, among other things, developing policies in relation to new and emerging technologies. I've had the privilege of being involved in work around aviation and unmanned aircraft, or drones, as many people call them, for several years. So in 2015, I was involved in the initial process of developing the Part 101 and Part 102 rules, which is the rules framework that we use at the moment for most of these activities. And interestingly enough, I can still remember going to meetings in 2015 with the CAA, and there was one in particular where someone said, "Oh, well, should we think about how these rules would apply to aircraft with people on them?" And then we all considered it for about 30 seconds, and then I think broke out into spontaneous laughter because it just seemed so kind of unrealistic at the time. So it's been really fascinating to be involved in this since then, and to see, in the space of about 6 years since then, we've just transitioned to a completely different world where our biggest problem is really how we keep up with the demand and resource this sort of work, which in the scheme of things is a nice problem to have. So yeah, really keen to be here today and excited to be part of the panel.
Thanks, Richard. Over to you, Steve.
Hey, thanks very much, Armin, and thanks to ITS New Zealand for inviting me along. I guess I'm the new old guy on the block here in the emerging technology space. I've been appointed very recently as Director Emerging Technologies Program at the Civil Aviation Authority. And at the moment, I'm scoping the possible formation of an emerging technologies unit. And what we're focused on here is being able to network, cooperate, coordinate, and collaborate across the sector to make sure that we take a systems approach to this new technology, and that we together introduce this new technology in a safe and effective way for everybody involved. So as you can see from the photographs there, I've been involved in New Southern Sky. I've handed that over, that program. The program is still running for 3 years yet, but it's very much around stakeholder participation and stakeholder involvement and making sure that we take that systems approach, hence the got ADSB yet sign in the right-hand photograph. So looking forward to talking to you with the rest of the panel. Thanks very much.
Great, thanks, Steve. Jude, some nice, nice pictures here.
Yes, not so attractive as those gone previously. So apologies for that. But yeah, my face should be enough. Thanks, Armin, and yeah, thanks for the invite to join the panel this evening. First of all, I'd just like to pass on apologies from Joe Mackay, who was originally scheduled to participate in this panel. Unfortunately, has other commitments, so you've got to put with me instead. So as the slide says, I'm the program manager for the AITP, which is the Airspace Integration Trials program. That's a program that was established in 2019 with a vision to make New Zealand a location of choice for the safe development, testing and market validation of advanced unmanned aircraft and adjacent technologies. It's a program that is led by MBIE, but partners very closely with the CAA, Ministry of Transport and Airways. So I work very closely with all of the other partners on the call this evening on pretty much a daily basis. For myself, I've got an aviation background and an aerospace engineering background, I guess. 18 years in the Royal Air Force in the UK and 5 years here. Actually worked with Steve and Shaun, both in the Royal New Zealand Air Force, and spent some time managing an aircraft production company here in New Zealand. Yeah, really pleased to be part of the panel tonight, and super excited to be discussing some of the innovative stuff that is happening in New Zealand.
Great, very, very good. Thanks, Jude. Anna.
Yeah.
You probably don't need an introduction because most people probably have heard of Wisk, but over to you.
For those that don't, kia ora, tēnā koutou katoa. My name is Anna Kominik. I'm the Asia Pacific Director for Wisk. So for those of you who don't know us, we're developing one of the world's first self-flying all-electric air taxis. We're obviously in New Zealand because of Richard's moment of inspiration in the Part 102 regulations. We're a joint venture between the Boeing Company and Kitty Hawk Corporation in California. We've been in New Zealand for the past 5 years, and we've been developing our aircraft for the past 11 years, both in the United States and in New Zealand. So we have a 5th generation aircraft, which you can see flying there. We've logged about 1,500 test flights on that, on our full-scale aircraft across both our sites in the US and New Zealand. And we're working hard not just on the aircraft, but also on the wider ecosystem. So the regulatory environment for integrating safely into airspace and working with communities, iwi, as well as cities and governments across the Asia Pacific actually, on how to bring aircraft like ours to market. And it is so early in the industry that actually there's a huge amount of collaboration across the different companies that are all entering into this space, because so many of the regulatory and community and social license challenges are things that we're all facing. So better to work together. So as well as my day job, working with the cities and regulators across the Asia Pacific for Wisk, I'm on the CASA Advanced Aviation Industry Advisory Group for the Australian government, and I'm an Asia Australia Director on the International Board of the Vertical Flight Society. So not a lot of sleep at the moment, but having an amazing time and just see this huge potential, not just for industries and companies like ours, but also for New Zealand as we really take advantage of this zero emission technology.
So this is the 5th generation, is it, on these photos?
This is the 5th generation aircraft.
Yeah, nice one. Very
interesting. And that's our team down at the Tekapo hangar.
Very inspiring. Thanks, Anna. Great. And last but not least, Shaun.
Kia ora, everyone. Shaun Johnson's Chief Executive of Merlin Labs New Zealand. We developed the a takeoff to touchdown autonomy system that's coupled with an artificial intelligence that can communicate with air traffic control and integrate into an existing aerospace system, just like a normal piloted aircraft can. So we've been working on that project for the past 3 years in the United States. We've got our autonomy system working on 5 different aircraft types, from very small to very large. And we're bringing this capability to New Zealand to work with the New Zealand Civil Aviation Authority to go through the certification activities. And as many of you will know, it's one thing to get something working. In fact, you can pretty much do anything you like these days, but to get it certified and get it commercially ready is a big challenge in itself. So that's what we're coming to New Zealand to do, and we're excited about working with the CA in that space. Myself, as Jude alluded to, 27 years in the Air Force, I think it was, as an engineering officer, and then 6 years at the Civil Aviation Authority as the head of certification there. And I've been with Merlin for about a year. Engineer by background. When I was still in the engineering space, I specialised in the later years in complex avionics and software certification, and then more later than that, certification of aerospace products. So that's me.
Thanks, Shaun. And in terms of New Zealand, great place to do it.
Very much.
That brings us to our first question. And I'll be going to you first, Richard, for this one, from a broader perspective. So the government released its draft emissions reduction plan earlier this week on Tuesday. In terms of that, there's a key consideration to achieve emission reduction targets. And it's really all about having a well-integrated transport system as well. What does integration with a broader transport system look like for urban air mobility to support our path to net zero?
Cool. So I might tackle that one in 2 parts, I think, and break that down into 2 questions. So the first one is, how does this integrate into the broader transport system? And I think there can be a perception out there that because this technology is being developed by the private sector, it's kind of as simple as the developers buying up some land, building a vertiport, and then, hey presto, we've got urban air mobility. But I think it's going to be a hell of a lot more complicated than that. I think there's going to be a lot of stakeholders that want to be involved in thinking about how this will fit within the transport system that we've got now. I think it's going to be its own thing. It's not a matter of, is this going to replace cars, or is this going to replace aviation as we know it today? I think it's a technology that will find its own place in the transport system, and it will be useful for some types of trips, and it will be less useful for other types of trips. And I think we still need to work out exactly what that looks like. But one of the key things there around having a well-integrated system, I think, is making sure that people are thinking well in advance about how this fits with their transport goals and what the kind of high-level outcomes are that they're looking for. And then thinking about how that translates at a spatial level in terms of, where do you put the infrastructure you need to support a network of urban air mobility services. So I think it's really complex, and there's lots of things we don't really know yet. But there's going to be lots of issues to consider, like noise profiles, and whether you have dedicated air corridors across cities. So there's going to be lots and lots of planning that goes into that. And I guess, the key thing that I think about and encourage people to think about is, this isn't here yet, but we have long-term transport plans and long-term spatial plans for a reason. And now is the time to start thinking about where it might fit within an urban area, and how it might be used interregionally as well. So that's probably the first question. I think the second question there is, how does it support our path towards net zero? And look, I think it's mostly a really positive story to tell there. So, it's amazing how electric aircraft technology has developed in the last few years. It's getting cheaper and lighter, and that's a really promising thing. Probably the key message there, though, is I don't think it's quite that simple, because I think everything uses energy, and we do have to be thinking about what sort of activities they're replacing or substituting for. So just because it's got zero tailpipe emissions, it doesn't necessarily mean that it's low emissions in the whole. So we do need to think about it kind of in that holistic system-wide view, and also think about the life cycle emissions and all of that sort of thing. But I think New Zealand is really well placed in that regard, given that we've got such high levels of renewable electricity. And so I think it's a big opportunity, and particularly something that could really help decarbonize the aviation sector, which is just a huge source of emissions and really difficult to decarbonize. So I think there's lots of promising areas where it could contribute to net zero.
So you talked a little bit about what I inferred as cost-benefit analysis there, Richard. Would you expect that the outcomes will be different at a jurisdictional versus at a national level? And it comes down to sort of the morphological and structural, I guess, makeup of our cities versus other urban environments.
Yeah, I think it's going to be really situation dependent. I don't think it's something where you can look at it and judge its impact in every environment. So all of these impacts that we'll talk about today, we have to think about how it kind of fits in with the existing transport system, and that looks very different in New Zealand to other countries, and very different within certain parts of New Zealand.
Great, thank you. I'll actually go to you, Jude. If you can maybe talk from an AITP perspective around how it fits in within our existing airspace, with the existing way that we're using it.
Yeah, sure. I mean, and yeah, definitely build on what Richard's saying with a view to covering off some of that existing aspects as well. Yeah, Richard made a really good point about us having a really good opportunity to build on the natural resources in New Zealand through the amount of renewable energy we have, and obviously that has advantages for powering electric aircraft. But I guess we should also not ignore those elements of our urban mobility that will not be electrically powered. So we've got the likes of Merlin's aircraft development activities, converting existing type certified aircraft, which could potentially be converted to electrical propulsion in the future, but maybe an easier path which would align with decarbonising the broader aviation environment is the potential to move to sustainable aviation fuels. The recent partnership, the government partnership with Air New Zealand, should assist that and definitely examine whether that is a viable option for New Zealand as we progress. Another use of all that renewable energy source could be to generate hydrogen, which is also another energy dense, potentially viable fuel source, whether we're using that as to combust or we're using it to power fuel cells which generate electricity, again to provide propulsion on board. So a number of opportunities there, I feel, to assist in decarbonising the aviation system within New Zealand more broadly than just electrical propulsion.
Yeah, fully agree, and I think it's important to consider a balance of options as part of that. So thank you. That'll take us to the next question. And so this one, I'm going to go to you, Anna. So the Infrastructure Commission published its draft 30-year strategy onto its website this week. The public consultation that was done previously identified a lack of public transport and time to get around our cities as key issues. Will urban air mobility change that, and why do you think that it would?
Yeah, so I think there's sort of, in tackling this question, there's two parts to it. And one is the opportunities that obviously advanced air mobility provides for cities. But the second that I just want to talk about a little bit first, because I think it's quite important to have it as a foundation, because, a lot of people look to advanced air mobility to say, it's going to fix transport, public transport woes. I think there's a societal aspect to this question, and that is really about inequality in our citizens' ability to actually access public transport. And that's actually a tougher question that we definitely need to be addressing in terms of the accessibility question. But it's actually deeper than just it's the form and the function discussion, right? So how do people actually, are they able to actually access that transport easily and in ways that is meaningful for them, and that can touch on infrastructure and urban planning as well as the actual transport system itself. But in terms of the opportunities that advanced air mobility done well should be able to provide, it is obviously utilising a resource that we currently arguably could do more with. And when it comes to ground-based infrastructure, roads, tunnels, bridges, rail lines, they all require a significant investment and often, disruption and displacement. And then, of course, you've got to maintain them. So from the use of airspace as a resource, I think there's a huge opportunity for advanced air mobility and urban air mobility, like what we're producing, is to actually support that middle mile, transport. And that can be quite a long way. That can be up to sort of 90, 100 kilometres. So we're talking about, large areas. What it does do is it starts to think about or starts to contribute to a different way of looking at our cities. So, rather than concentration in the CBD, it actually supports people to live further out but still to be able to come into the city. And it's some of the work that we've been doing with some overseas jurisdictions and overseas cities. They're looking at this much more from an urban planning, post-COVID urban planning perspective of how can urban air mobility connect with public transport nodes to actually also support all of those people who are actually moving out of the cities to essentially cheaper housing, but they still are either doing work from home or they want to be able to commute into the city without that all having to be forced onto land transport. So I think, in terms of what this could mean for the next 30 years is that we could be thinking very differently in terms of what our cities look like and how we're actually using these sort of middle mile, aircraft to actually support the way we live and creating those options for us to live differently from that sort of concentration of urban housing that we currently have. So lots of really interesting things there. And certainly if you look at the cargo side of things, that also opens up, huge opportunities. I'm hugely passionate about electric aircraft full stop, because they're, not just because we're developing one, but because of the opportunities they create for, those shorter hops. They're 30% cheaper to actually run. It means that actually suddenly you have the opportunity to run sort of smaller networks, shorter networks that can actually connect people in different ways. So you suddenly, those shorter hops, even Hamilton to Tauranga or Tauranga to, Gisborne, or some of these will start to open up regions in a way that we haven't seen before. So there is real disruption coming. You can see it and you can feel it. Exactly how that plays out, is really in our hands. And we're really firm believers that we should be talking about this actively to actually determine what do we want from this industry, how do we want to use it, so we don't take what has been a traditional kind of approach, and particularly in aviation, of a reactive approach. It's here and we have to react to it. Let's think about it proactively.
Right. Thanks, Anna. So you talked a little bit about the cost effectiveness of electrification there. In terms of cost effectiveness, I know that your craft is also autonomous. Does that make a big difference? And in terms of middle mile transport, when we're talking about other forms, for example, land-based transport, do you think that there is a target, that's achievable in the future where urban e-mobility will be cost-effective in comparison?
Yeah, I mean, it is cheaper to actually run, and particularly, when you're actually, even when you're in a multimodal component, it's actually works, perfectly well from a business perspective in terms of the business modelling. I think one of the things that I would say is that the way we actually construct those multimodal networks and the way we integrate that with public transport will be a key to making it accessible to the general public and as many people in the general public as possible. We're doing some work with Los Angeles City at the moment around hard to reach communities, and actually how do we create those networks and those nodes so that people can access them really easily. So I think electric aviation is going to create this opportunity for essentially democratizing the airspace so people can take advantage of it. We just need to be thinking about how do we, what do communities want out of that? What is acceptable, noise level, safety, visual pollution, all of that side of things.
Great. Yeah, I think that puts it up very much on balance. Thanks, Anna. Does anyone else want to have a go at answering the question? No one? So you're smiling there, Richard. Do you want to give us your 2 cents worth?
I guess I agree with most of what Anna's said there. I think, it's a question of scale here as well. I mean, if you think about the number of trips that are made by public transport each year, it's, tens of millions in Auckland, and that represents a very small portion of total trips in New Zealand. So, I don't think all of these issues can be addressed through advanced air mobility. I think it's a matter of being one tool in the toolbox to help address some of these problems, but it's not going to be the panacea to all of the problems we've got.
Yeah, so it's no longer a binary; it's more of an all modes supporting the end goal.
Exactly.
Yeah, I would say that there is one thing that seems to be ubiquitous across the different platforms in urban air mobility, and that is the drive towards autonomy. And that event, that's going to be a whole thing in itself. It doesn't necessarily help it. It helps the scaling up, but Richard's absolutely right. It's not going to, for example, necessarily replace an entire trainload of commuters. But what it may do is actually make it easier for people to be, for example, living in an area that we wouldn't at the moment consider to be within that network, and to be able to get those people to a transport node more easily and without having to use, carbon burning cars or whatever it is. So it opens up other opportunities, and with the autonomy side, that then starts to make that more scalable. A lot of people ask us, why are we going straight to autonomy when others are starting with a pilot? When it's not just because we're completely nuts, it's also because we're really looking at what is scalable, what is actually going to happen, in the future, and everybody in the urban air mobility is driving towards that. I mean, even our long haul aircraft are driving towards that. I mean, that's where Shaun comes in too.
Yeah, definitely about accessibility amongst other things, and I'll refrain from getting more into that because we've got another question coming up about equitable transition. So we'll go to the next question. How do we ensure urban air mobility as a form of transport is equitable and provides a just transition from traditional forms of transport in New Zealand? I know you've already talked about this, Anna. Do you want to add anything, or if anyone else wants to provide an answer?
The only thing I was going to say is that I just think social license is just a really key part of this, and I just think we have to get a lot more sophisticated as to how we look at transport. It's sort of, as I said, it's that how do we actually connect it with public transport nodes? You know, what is the infrastructure that is required, and what do we expect of that? So, you know, those would be my key points.
Yeah, I think from my perspective, I think we have to be a bit realistic about what the goal is here, and also think about what we mean by equitable. If you look at aviation today, it's not a particularly equitable form of transport, and it's not because it discriminates against people. It's just that it's expensive, and things that are expensive are always going to be disproportionately used by people who can afford them. And so I think the potential here is that if you can take out a lot of those costs through electrification or autonomy, you're taking something that is currently quite exclusive and making it available for a heck of a lot more people, which is a really good thing. But I also think, you know, we've got to recognize that there's a lot of people out there who struggle to pay for the cost of a bus ticket. And we're never going to get to the point where, you know, we go, well, how do we address equity issues? Well, let's put a vertiport in people's backyard, and you know, I think it has potential to make things more equitable, but I think having kind of complete equity for all modes as a goal is not particularly realistic. And the other thing I'd say on this one is I think the key thing that we need to think about is making sure that the externalities aren't distributed in an equitable way. So, you know, most people don't like things flying over their property and making a lot of noise, you know, so we have to think really carefully about how we do that in a way where we're planning that sensibly, and it's not just the people who have the resources to complain who are getting their way.
Yeah, so definitely about those positive distributive outcomes. Yeah. Cool.
I think we also need to think a little more holistically than just the direct effects of the transport as well. I was speaking to a gentleman on the west coast of the South Island who was very passionate about urban air mobility, and his vision was that it's much more than the Christchurch folk who could then buy a house that's much cheaper on the west coast. It's about how that then opens up opportunities for people on the west coast and their businesses. So suddenly there are more dairies, there are more supermarkets, there are more cleaners, there are more schools, there are more, all of those things. So the question of equity, I think you need to think about a little bit more holistically than just the users of the transport, and what the net effect of opening up transport opportunities like this will have on a broader community, particularly in rural New Zealand.
Yeah, very valid point. Thanks, Shaun. Cool. We'll go to the next question. So how do we assess the impact of drones or flying taxi, as it might be, full life cycle on the environment in terms of noise, privacy, safety, and obtain public support of the transport mode for the future?
So I think you wanted me to start this off, Armin. It's Steve.
Yeah.
Yeah, look, obviously from the Civil Aviation Authority's perspective, the first thing that we're concerned about is public safety. Public safety is paramount. And it's fair to say that emerging aviation technology will go through the same rigorous standards as traditional aviation to ensure safety and reliability. And throughout the life cycle, you know, Shaun will tell you that that was one of the things about the certification team were very keen on in the CA and still look at very closely, and that is the ability to support a system and its safety and maintenance of that safety, sustainability of that safety right throughout the life cycle of whatever platform it happens to be. So the other thing is that we know that how you know, aviation accidents in the past have significantly impacted the tourist trade from overseas, and we need to be very careful to ensure that public confidence in new systems is imbued from day one, but is then maintained all the way through, because it has a or it could have a very significant impact on the uptake, distribution, and the continuing success of some of these systems as they come in. So, that's the safety aspect. The privacy and the noise aspects are not necessarily CAA's concern, but the whole thing's going to be taken as a package, so we can't ignore them. So, for example, the noise issue, whilst the CAA shares responsibility for noise, the CAA's responsibility lies really in flight paths, particularly approaches, departures from aerodromes. And I guess the same thing would it will apply to the departure and arrival of these sorts of new platforms. So, but there is the local authorities will be concerned with noise. Urban authorities in particular will be concerned with noise. And as Richard pointed out, there's an equity issue over that, and the ability to have social license and a fair distribution of noise when it comes to that. The privacy issues are more in the bailiwick of the Privacy Commissioner, and although, funnily enough, the CA gets a lot of reports of privacy or invasion of privacy that's perceived by the public around drones. It's not really a normally, a safety issue in the aviation space. But what needs to happen here, and this is the bit about getting back to the Emerging Technologies Program and our role, is to join people up in this space and make sure that the system perspectives of these issues are taken together, and they're not taken separately. So that the system perspective needs the various parts of the system, the Privacy Commission, the local authorities, the CAA, everybody concerned to engage with one another and have the same picture and be able to deal with the system effects in a balanced and system way. So that's really a summary of how these issues will, I guess, pan out against the life cycle, against the environmental issues that we've put up here, and I'd be keen to understand what the rest of the panel think.
Yeah. Great. As I understand it, also your certification process takes some of these things into account, doesn't it, Steve?
Look, the certification does, as I said at the beginning, it does take into account the life cycle of the platform and how it's going to be used. And of course, if that use changes, then that will impact the exposition and the certification of the platform as well. So there's a whole bunch of things here that may impact the life cycle issues, and they may have to be revisited during the life of the platform, particularly if it's its role changes or the context in which it's being used changes, or potentially where it operates changes. But Shaun's the expert on certification.
So Richard, do you want to maybe, I know you've had quite a lot of involvement as being a chair for International Transport Forum in other places as well. Do you want to maybe talk a little bit from your side of this?
Yeah, sure. I mean, maybe I'll just touch on a couple of the things that are less specific to the CAA, so the noise and privacy issues. So on noise, I think one of the difficulties is that we're seeing so many different types of aircraft. Previously in aviation, the noise profiles were quite consistent and predictable because there were less kind of range in aircraft type, and they all had the same propulsion mechanism. It's been easier to manage in that regard. So one of the challenges with drones, if you look at the full spectrum of drones and electric aircraft, is that there are so many of them, and they all have quite different noise profiles. So one of the things I was kind of interested in finding out recently was that it's not just the decibel level as well, it's also the frequency and the pitch of the noise. So that one, you know, I think at the end of the day, there's going to need to be some new frameworks developed to, I guess, measure and monitor different types of noise and think about the different kind of restrictions that you would put around different types of operations. So that's a really complex area, and I think it's actually going to be one of the toughest policy issues to address in this space, especially once they start kind of being promulgated around the community, and the public will expect to have a greater say in how all that's managed. Privacy, I think, if you're talking about I guess I'd start by saying we've got reasonably robust privacy laws already. And I think the big change that we're seeing here isn't that those laws aren't fit for purpose anymore. It's just that you've got different vectors for spying on people, or, you know, capturing and recording information. So in a way, we've already got frameworks for privacy, and I think the issue there is more around giving people confidence about you know, what the activity is and what its purpose is. So generally, if something is flying above you but you know what it is, you know what it's doing, you're less concerned about privacy. If a rescue helicopter flies above your head, you don't worry about privacy because you know what it's doing and what it's there for. So I think with advanced air mobility, that's less of an issue because it will be reasonably self-evident that it's there to carry passengers. With some of the smaller drones that we're seeing, it's going to be a major issue. And I won't go into detail, but we are looking at tools that we're putting in place to try to make it easier to identify people and understand what they're doing.
Yeah. And I guess a lot of this also comes down to that comm strategy, you know, I guess from public authority and you know, at a national level as well. So that can be as early as possible. Then I think that there'll be more buy-in to it from the public.
Yeah.
Cool.
Next question. A couple of comments on that last one.
Yep. Sorry. Go ahead.
Yeah. So look, certification piece. Steve's right. Certification is all about the intended use. So there's been a couple of fundamental changes over the last decade on how products are certified, and one of the great outcomes of all of that is actually you've got to upfront consider how the product's going to be used and how it's going to be supported through life. So those pieces are already part of the certification framework. On the noise front, yeah, look, I'm hearing what Richard was explaining. The great news is now that NASA don't have to carry William Shatner into space. They've got lots of capacity to do things like come up with these new standards and do really detailed studies on things like noise profile for electric propulsion. And so there's a great amount of work going on at this time around the world for standards such as that, including standards on artificial intelligence and how that's integrated into airspace as well. In the safety area, I think it's important to note that, and I've got a question coming up and I was saving this point, but it was 114 years ago that the first autopilot was brought into aviation, and autopilots have become more and more complex and more part of day-to-day flying because of the safety aspects that they bring. So if you think that full autonomy is a generation beyond a standard autopilot, the focus from all of us that are in the autonomy space is enhancing safety first and foremost. The majority, and I mean vast majority, of air accidents to this day are sadly human error. It's very, 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 very rare that there is a true mechanical failure that isn't actually traced back to a human error. So the safety advantages that autonomy bring, coupled with a safety pilot in some cases, or just purely autonomous air mobility or air freight transport, are something that all of us in the space are focused on. And as I say, it's an extension of what's already happening now.
And so, Shaun, I saw you were on 7 Sharp the other night as well. So you
wasn't me, it was my double.
So I saw you talking about, you know, what your you know, artificial intelligence software can do, you know, with the landing of the plane. Is that a place where you see, or where you've seen that there's been a lot of that error that you talked about occurring in that space, or has it been more, it's, you know, just flying
Yeah, I think, you know, the landing something that most modern aircraft can do now. It's just that the feature's not allowed to be used or not enabled depending on the runway that you have. If you look at something like the 787 systems can, without GPS, artificially create a landing profile for a runway and land the aircraft using onboard inertials and stuff. So the en route, the landing, it's all there now. And it's mostly with ground aids like instrument landing systems, but it's all there now. The takeoff bit, not a lot of research or not a lot of work has gone on that space, but that's what all of us in the autonomy space are putting a lot of energy into. And of course, bringing all those things together in a way that integrates with existing airspace users is a secret. And I think, and I'll touch on it later, but the social license piece and building the public trust, and I think Steve touched on that as well, is key to our success as well.
Great, thank you.
I'll just throw something real quickly there, yep. Armin. Just building on that privacy piece. Probably about 12 months ago now, a Colmar Brunton survey, which was commissioned by MBIE and MOT, actually showed that people in general were more comfortable flying in a fully autonomous aircraft than they were having a small drone fly over their back garden. Mm-hmm. Which was an interesting point that came out of it, but really shows that public perception around the use of drones and the social license really is a key. And if we don't get that and we don't secure that public acceptance, the technology development really is pointless. But I think Shaun was going to touch on that some more in his point, so I won't carry on.
Great. And so I'm just conscious of time, so we'll go to the next question, and I think that's one of the last questions, but we just want to allow some time for audience questions as well. So how far away do you think we are from having autonomous air mobility available for widespread domestic public aviation in New Zealand? I think this actually is the last question. If you can answer that in 30 seconds or less. Or
I've already partially answered it 114 years ago.
Oh, yeah.
So look, as I sort of alluded to before, the autonomy question: how far are we away from true autonomous air transport in New Zealand? It's a complex question. So I think freight moving up and down the country, absolutely within the next 5 years, it's achievable. Even considering the certification challenges that lay ahead for that. People, fully autonomous people, again in this decade, definitely. I think the technical challenges, the certification challenges, the standards that need to apply, they all either exist right now or are being worked on frantically by really big organisations such as NASA, such as EASA. Really, the bit that it behoves us all to concentrate on is the social license piece and building that public trust and awareness of what we do. It's quite amazing. I always bring out this with friends when they look at me strangely about what I'm involved with now, and say to me, "Oh, geez, I'd never get in an aircraft that flies itself." And I said, "Oh, have you ever flown into Queenstown? Do you know the pilot's not allowed to touch the controls on that final bit of approach into Queenstown? The approach can only be flown in by autopilot. It's only at the last 400 feet, I think it's 450 feet, that the pilot sees the runway and then takes control of the aircraft." I mean, so autonomy to a large extent is already with us now, and is safe and is reliable and is trusted by people. It's just that they're not aware of it. So building that awareness, and then building the awareness around how we step in through a very crawl, walk, run approach that chins the bar with all the standards that the regulators set is really the way forward. And I know for a fact that all of the startups in this space in New Zealand and around the world are all working towards that goal.
Yeah, and I think when it comes to autonomous travel or aviation, it also comes down to that incremental approach. Just like land transport, there are different levels of automation or autonomous travel, and so I think it's just making sure that there is I guess support and buy-in and understanding along that trajectory all the way through to full automation.
And airspace integration is another key part of this picture as well. You know, there's a lot of work being done. CAS is actually looking at the moment in terms of actually doing a review of how they structure airspace to actually create those opportunities for the future. There's a lot of work being done outside of New Zealand that we can leverage from. This is a really great opportunity for, you know, actually aligning ourselves with our friends, you know, in different places to actually learn what they are learning and working out what works for New Zealand. And the other one that I would say is just that with autonomous air mobility, it has, you know, no company is going to push out something that isn't safe, because that company will be gone if something goes wrong. Any one of us knows that we have one thing go wrong, that's us, we're out of here. So you know, that's not what we're here for. We're here to actually be safe, be useful, and be part of the ecosystem in a way that is real. And you know, most of these companies, you know, ours included, you know, your profitability is a long way away. So doing it right from the get-go is the most important thing. This is not about, at this stage, it's not about the business, it's actually about doing it right. And I think that's got to be, isn't always fully appreciated. Yeah,
and I've seen that safety first part of your vision as well, both Shaun and Anna. So that's great to see. Thank you. Cool. In 30 seconds or less, what is one use case that you're most excited about for New Zealand with regard to autonomous air mobility or aviation, and why? And so I'll just go to everyone for this, maybe starting with you, Jude.
Yeah, sure. So for me, I guess the excitement comes from how much value we can add to people's lives, and I really see the ability to connect remote communities being one of the easiest ways to do that in the short term. Bringing those people in, offering them services that would traditionally be unavailable through the use of autonomous unmanned air vehicles is a clear way to do that.
Great, thank you. Richard.
Jude probably took my one. I think interregional transport is a good one, but the other thing I'm quite excited by is the potential to use drones to do delivery of urgent medical goods, which we're seeing overseas a lot. And I think those sorts of use cases are really important for building social license.
Yeah, great. Thank you. Steve.
Yeah, look, the one thing that I'm really excited about is integration of all these systems. We've got an aviation system that is existing at the moment. It will have to adapt and change to allow these things to fit in. And the integration challenge is not something we should take lightly. What Anna said about airspace is absolutely right. We're going to have to have a rethink about airspace. We're going to have to be much more flexible and adaptable, and concepts like the flexible use of airspace are going to have to be examined and used to make this work. So integration is the exciting challenge for us, I think.
Yeah, so what would you say they would include? So generative and transformative policy as well?
Can you tell me what exactly you mean by that? That could mean 1,000 things.
Oh, yeah, well, so I guess I'm talking more around sort of, versus linear and incremental, more sort of transforming, like you said, around the integration piece of it, and thinking out, I guess longer term into the future, to think about how we can sort of transform the industry.
Look, I think there's so many new technologies coming along that will be entering the system transitionally. It's going to be difficult to just go switch. We're going to go to this tomorrow. So it's going to be more evolution than revolution. But that evolution's got to have flexible systems that allow us to adopt and adapt and change. And that's really going to be the key to it.
Great, thank you, Shaun. 30 seconds or less.
Yeah, I'm going to go a bit different on this one. I actually think I'm most excited about the opportunities that this technology presents to encourage young people into STEM programs, so that we can, in the future, migrate our workforce from or our economy that's one reliant on farming and agriculture to technology. That to me is the greatest opportunity that we have here.
Great. Thank you. And Anna, 30 seconds or less.
Yeah, just picking up on what Shaun's saying, the halo effect of having industry and emerging industry like advanced air mobility in New Zealand is just incredible. You know, you only have to look at NASA, Mars, you know, expedition actually created or helped us build infant formula. These things are often in completely different areas, but they create these opportunities for us to transform our lives in lots of different ways. One very practical thing that I really want to see in New Zealand is search and rescue through these autonomous air mobility options. Whakaari would be, you know, one option where we could have been sending in autonomous vehicles, perhaps to some good effect for the people affected by a huge natural disaster like that, or Christchurch earthquake as well. So, you know, there are options for us to actually use this technology in really good ways.
Great, thank you. And just cognizant of time, is everyone okay to stick around for some audience questions?
Sure.
Sure. Great, thank you. Over to you.
Being out of doing dinner, so that's good.
Over to you, Simon.
Great, thanks everyone. I've really enjoyed it, and great to hear what your different visions are and where you think the opportunities are. Just a couple of quick questions. Quickly, we'll get those to Anna. I think at one point you said the 30% cheaper to run. This is a question from Joe Chang at Wakakatahi. And specifically, is this compared to non-electric flight?
It is correct.
Yes.
Yeah, that is correct.
Mm-hmm. Another one for Anna, again, from Rich Mitchell, who's at Oricon. The noise level of Wisk, how does that compare to a similar sized, say, 4-passenger helicopter?
Richard and Shaun can probably talk about that. It's quite a different profile. So picking up on what Richard said, in terms of, so it's much less than a smaller helicopter, but a very, very different noise profile. So we've done a huge amount of work ourselves, but also now doing it with NASA on how to create those noise profiles so that actually they are, you know, they minimize the noise that they actually make, particularly on takeoff and landing. So when we're on the vertical takeoff and landing, that's where most of the noise is. When they're on the wing, they're virtually silent. So because they're electric. So think about your cars, but it's like a whirring sound would probably be the best way to describe it. Richard or Shaun, you can probably give a bit of a sense of what the profile sounds like.
I think what was most interesting, so I was really fortunate to recently fly the Pipistrel Electra, Gary Friedman's aircraft out of Christchurch. We brought it up to Paraparaumu to Kapiti Airfield, and it was incredible how many people came to fly it and see it. And there were a bunch of us standing out front of the Aero Club on one of the takeoffs, and it was a really amazing moment because it had climbed out. It was at about 600 feet or 800 feet above us, and a Cessna 172 from Wellington went over the top of the airfield at 1,500 feet, and all you could hear at 1,500 feet was the Cessna 172. You couldn't hear a thing of the Electra. So I agree, that very different noise profile, different frequency considerations, annoying at different phases of flight, if you think of the annoyance of an aircraft. But for the whole, quite a bit more less environmental impact in the majority of phases of flight, I guess is a way to put it.
Great. Well, Rich has come in and clarified where he's coming from, giving us a bit more context, actually. So you don't mind if we carry on with this one before we move on to another question. He's thinking specifically in terms of urban air mobility, and say if you're landing in a city centre, I guess, you know, we've got helicopter landing pads on building rooftops, which don't get used very much here in New Zealand. But if it was that kind of scenario, would office workers hear it in the building below or in the surrounding streets?
I'll jump in really quickly on that one. The ministry's office is right next to a helipad. I've never noticed it while I've worked here. So I think as Shaun and Anna were saying, there's always going to be noise. There's some annoying laws of physics that get in the way. But on the whole, I think it's quieter than other noises that people are used to in the city centre. I mean, diesel buses as well, hugely noisy. So I think the bigger concern for me would be residential areas. I think that's the bigger issue to think about.
Yeah, we're doing some work in a city in another jurisdiction, and actually one of the really interesting things about your vertipads on top of buildings is also where is your most valuable property in a building. Tends to be in an apartment building, tends to be penthouses, and just the impact of downwash and all of those aspects of us operating our vehicle are actually quite significant. So, actually there's a whole lot of aspects to this. So we're actually working with a property developer who's developing one of the first buildings to actually accommodate air taxis on the roof in a way that doesn't impact on the residents. So really, it's got so many different parts to this puzzle. It's insane.
So pushing water out of the infinity pools of those penthouses, I can imagine.
Yeah, you've got it. You can't have your balcony doors open necessarily unless you have some pretty impressive structures over the top. So yeah.
Cool.
As noise is actually wasted energy, right?
Yeah.
So
exactly.
it's particularly in the urban air mobility, the vertical takeoff and landing aircraft. Every bit of noise they can remove is more safe for flight. So it's a problem that actually it's in the best interests of the companies that are developing these technologies to solve. And we're fortunate to be in a time where composites and rapid prototyped or additive manufactured components are now able to be used in aviation. So they open more and more opportunities to reduce noise as well.
Thank you. Any more additions to that one? It's a fascinating one to explore. We've got a question from Amy Strang, who is she's one of our YTP ambassadors, an ITS New Zealand director, but she's also happens to be at Air New Zealand these days. So her question is what do we think the biggest challenges with urban air mobility in New Zealand? What is the biggest challenge? Maybe you can do a quick whip around and some short answers for that one. Where would you like to start?
I'll start that one. For me,
you.
that's quite clear. Social license and public acceptance. If we don't achieve that, everything else that goes below is pointless. So that for me, that's the biggest challenge and the biggest hurdle to overcome.
So for me, I think the big issue at the moment is just safety and kind of getting to that safety threshold and being able to demonstrate that it's safe. So I think it's really tough to bring a new technology into the aviation system because it's a system that actually has a ridiculously good safety record and there is zero tolerance for crashes in the aviation system. So you compare that to land transport where you only have to be better than human drivers who are typically terrible. For these technologies, you're basically entering a system where there is already zero tolerance, and I think that's the challenge. It's not necessarily meeting that challenge; it's being able to demonstrate that you've met that challenge and have everyone agree that you've met that challenge.
Similar in a way, then, Richard, to autonomous vehicles on the road. They have to meet a much higher bar before there's acceptance of it. Yeah,
although I mean, I think that bar is higher than a human driver, but it is definitely a lower bar than a commercial airline would have to meet. So it's risk is not the same across different modes. It's all based on context and what people have come to accept.
Great.
So just to tack on to those two answers, it's about public perception. Some people don't realize that this is actually going to be with us. It will be with us. Not in the immediate future, but very, very close future. And, it's interesting what they're forming in terms of perception at the moment. All those issues that have been covered by Jude and Richard are in the mix. So it's going to be interesting how the communication of the benefits are going to fall on the public perception over the next couple of years. I think that's going to be really important.
Mm-hmm.
And I'll just wrap up. I mean, there's actually 5 things that we think of as the pillars that you can't actually do without any of them, and you can't, allow any of them to fall behind or get too far in front. And that's infrastructure, your aircraft, your airspace, the operations themselves, and the community. So, all of those pillars are well recognised as being the things that hold up advanced air mobility, and all of those things are needed to actually ensure that we have safe, acceptable, worthwhile flight going on.
Great. Can I just...
Other challenges as well that I'll go out on a limb and say. One is the ability of our regulatory system to adapt to rapid change. And that's no criticism of anyone or any entity. It's just a fact of the way that our rulemaking process works. It's time consuming, difficult and expensive to change or adapt rules for some of these new technologies. So that's a real challenge. And I know the CA put a lot of effort into thinking about performance-based rulemaking and how we can be more adaptive and ready for change. So that is truly a significant challenge. For example, artificial intelligence brings a whole new set of rules, a whole new set of considerations and standards that we don't have at the moment in our regulatory system. So how do we either use existing rules to ensure that we're meeting the intent of those rules, or how do we incorporate new rules? And I think the other big challenge is the size. Unfortunately, our size as a nation is a great advantage, but equally it's a disadvantage. I mean, we have a capable but very small regulator. So the ability to get multiple companies, rapid change in decision, people that are across all of the various elements of a new technology that needs to be considered as a difficult challenge.
I guess at some point, as with all of these things, it gets a little bit political as well. Well, I mean, politicians love to get behind some nice shiny toys as well. So, maybe it works both ways.
Some don't.
A question, I'm just going to jump back to one of the questions that Armin posed and make it a little bit more specific. The use cases, I guess, is in terms of becoming a passenger transport solution in New Zealand's context. Are we thinking it's the geography that you're going to be able to overcome, or is it the benefit of taking that straight line in urban environments is the exciting challenge to address? Did I make myself clear? I guess in an urban environment, we're really moving towards trying to get people out of their personal vehicles and into mass transit, but mass transit tends to go along straight lines, and you may be able to overcome that more easily with an air vehicle. Or is it overcoming, the water hazards and mountainous hazards? Which one of those two is kind of more appealing to overcome?
I think it's probably both, to be honest. Actually, the thing with urban air mobility is that it takes away those challenges like the geography or the congestion that you're actually trying to solve for, right? So I do think in the interim, and we're talking about probably the next 20 years, it's more likely to be off public transport nodes to provide that kind of, taking your straight line analogy, it provides the bends and the curves for that public transport potentially in the future. But there's all sorts of, as we've discussed, there's all sorts of case studies and use cases for urban air mobility and advanced air mobility in urban environments. So I think we're yet to test what it's going to be best for in New Zealand. I do think actually the search and rescue is probably, and medical are probably going to be two things that really do start to prove its mettle from a New Zealand perspective. We're not, Jakarta or Los Angeles or even Sydney in terms of the congestion factor. Auckland is really the only city that has the same sort of congestion marker that we would be looking for to actually solve for specifically.
Apparently that's what one over $1 billion a year in
lost productivity.
Yeah.
Mm-hmm.
Yeah.
Here's another angle, Simon, that nobody's really touched on. Cargo and medical supplies delivery to time-sensitive items for remote communities. How many times do we have issues with roads being blocked by slips, with Kaikoura, things like that, where you can't get in and out of communities for days? What a boon that would be if we had the ability to resupply them with vehicles like this. And not hazard other lives at the same time. So I'd look at this. I think resilience is another characteristic of these new technologies that we shouldn't overlook.
Absolutely, yeah. I think that's one where you'd easily tick the social license box quite nicely there. People would easily come to terms with understanding what that role is, as Richard used the analogy of the rescue helicopter. Nobody's bothered by that. So if it's definitely serving a purpose like that, you'd get easily the acceptance, and maybe everything follows from that. We've come. Well, sorry, maybe I speak too soon. We may have one extra question. Here we go. Leah Murphy. Not sure where Leah's from. Sorry. What is the expected capacity of the passenger transport in the medium term? So.
Shaun can go first on that.
Shaun can go first, right?
How many do you want?
Exactly.
So look, our approach is we're developing an autonomy system that it's a tuning activity to put it into any aircraft. We've started with rattan, long, easy, and cozy, which are a single and a dual seater, and we've got a Twin Otter and a Caravan and a King Air, and we can go up to anything 737, 787. It's the certification challenges are different when you move up to that beyond 30 seats, but the sky's the limit. Anything that we can carry now with people, with a standard category aircraft, we can carry in an autonomous fashion. I guess the other part of that question is, are you talking about electric propulsion? Are you talking about a hybrid propulsion? Are you talking about a synthetic fuel propulsion system? And so that changes. I mean, the realities of the energy density of batteries are realities that there are some amazing leaps and bounds going on in battery design, but there will always be hard laws of physics to come up against for electric propulsion. So it's going to be a mixed mode, I think, a mixed mode of propulsion system, all of which can be without carbon, I feel.
Great. Let's hope so. We need to do it. That brings us to the end of our questions posed by the audience. So Armin, perhaps if you'd like to take back over, and unless there's any other questions from the panelists of each other.
We see each other every day, just
Great. Thank you. All right. Thanks, Simon. So just to finish off then, so ITS New Zealand does have some other events coming up. So we've got next week the ITS New Zealand YTP mentoring program launch. So that's one that ITS New Zealand and YTP have been working on for quite some time now, and really an important thing for us to put out there, and it's really something that we hold dear to our hearts. So we've got a keynote there from the Auckland University of Technology, and for those mentors and mentees that are attending that, we look forward to seeing you there. ITS New Zealand has got another event on the 28th of October. That's more of a lunchtime event around demand responsive transport. And we also have a ITS New Zealand AGM coming up, and that's well, at the moment we're looking, there's probably going to be quite a high profile speaker there, but at this stage we are still landing a date on that one. So I hope to see you at some of these events. And if you'd like to stay in touch, as I said at the start, we do have a website. We're also on LinkedIn, and if you're wanting to get in more of the young professional level, then also Young Professionals is also on our website, and we do have a LinkedIn as well. And just want to say a big thanks to everyone for joining us tonight. Thanks again to our panelists. It's been a fantastic conversation, and really, looking forward to these times coming ahead. Very inspiring. Yeah, thank you. And to our members, thanks so much to members. Yeah, couldn't have done it without you. And thanks for your continued support. Thank you. And that'll be the event for us.
Thanks, everyone.
Thanks, everyone. Good night.
Thank you.
Thank you.
Thank you, Armin. Good job.
Thanks.